Today we are going to look at steel making from a very different perspective. We'll explore a powerful analogy how diagonizing the giant heart of a steel plant, the blast furnace, is remarkably similar to how a doctor diagnoses a patient. This is the story of how an ancient art is transforming into modern science, blending human experience with a artificial intelligence to build a sustainable future. The core idea inspired by the think tanks in the blast furnaces is that the blast furnace is like a patient. Just an oriental doctor check a patient's pulse to understand their overall health. A blast furnace operator monitor the furnace digestion and discharging, that is the reduction of iron ore and tapping of the modern iron. For centuries in both medicine and steel making, the key to a successful diagnosis was experience and intuition. Let's look at how that traditional approach worked. Historically, operators were looking blind. It was impossible to see inside a furnace running at 1500 degrees Celsius. So, like a traditional doctor, they relied on gut feeling and indirect sign. They would judge combustion by looking through small holes or guess at internal blockages based on experience alone. Their job was to manage two key functions, the physical melting of ore and the chemical reduction that turn it into iron. This was truly an art form. Today, that art is being empowered by science. Modern blast furnaces are equipped with extensive sensor networks that act as the operator's eyes and ears. Think of it as a moving from simply taking a pulse to having a full suite of modern medical instrument. We are talking about around 550 thermocouples monitoring temperature and 100 pressure sensors tracking gas flow. This constant stream of data gives a detailed real-time picture of the blast furnace condition, much like medical tests reveal the human condition. This massive amount of data has paved the way for the next great leap, the digital revolution. We are now moving beyond human experience alone by leveraging artificial intelligence and deep learning. AI based operations can predict outcomes and automatically control the process to maximize productivity and reduce coal use. At POSCO, for example, AI model analyzed over 60,000 data sets on furnace blockages to solve chronic problems automatically. This is where operators know how is turned into a standardized intelligent action. So let's look at a practical example. A furnace's diet, its raw material is critical. Different materials like pellet and sinter have different properties, and a poor mix can cause digestive problems like poor fluidity and blockages. The AI solution digitalizes the properties of this raw material and uses deep learning to predict the outcome of various charging strategies. These allow for automated control, ensuring the furnace has an efficient and stable digestion process. Now, coming to our next slide, just like a healthy body needs a good circulation, a blast furnace needs balanced gas flow and temperature. Using new material or injecting hydrogen can save energy, but it can also create temperature imbalances that disrupt the process. The AI solution have here involved models that can predict the hot metal temperature and are in advance and automate control to maintain stability. This proactive approach ensures the furnace operates in a healthy, balanced state. And so, what's the goal of all these? A healthier, more efficient patient. This advanced diagnostic approach powered by AI leads to major improvements. We see increased productivity, reduced coal usage, and lower emission. A well diagnosed and precisely controlled furnace is a cornerstone of any company's strategies to reduce its carbon footprint. Looking ahead, this doctor's toolkit is evolving for a greener future. The principle of precise diagnosis are fundamental for transitioning to lower carbon methods. As we test technologies like hydrogen injection, these advanced diagnostic systems are essential for managing the new process condition safely and effectively. The knowledge we gain is directly informing the design of next generation technologies like one example is Pasco's Hyrex. The ultimate vision is to create intelligent virtual steel mills that can simulate the entire process to optimize for both cost and CO2 emission. So, in conclusion, the analogy of blast furnace as a patient provides a powerful framework for modern steelmaking. The operation has evolved from an art based and intuition to a precise science driven by data and AI. This is a continuous journey of improvement, and most importantly, this advanced diagnostic capability is not just about efficiency, it's a critical enabler for steel industry's journey towards decarbonization and achieving carbon neutrality by 2050.